Good morning, everyone. Welcome to today's Migrate to Azure PostgreSQL webinar. We are thrilled to have you here. My name is Allie Pickering, and I'm a client partner executive at Quadrant Technologies. In today's session, we're going to be diving into a critical topic for modernizing your infrastructure, migrating to PostgreSQL. As many of you know, businesses are increasingly turning to cloud-based solutions and modern database to streamline operations, reduce costs, and scale more efficiently. PostgreSQL, an open source relational database, has been gaining significant traction for its scalability, performance, and flexibility. Today, we're going to explore how to make that switch and what that migration journey looks like. So, why Azure PostgreSQL? We'll begin by exploring the unique value proposition of Azure PostgreSQL. Azure PostgreSQL latest features. We'll showcase some of the latest features from enhanced security to enhanced analytics capabilities. We'll walk you through how these updates can empower your database operations. Then we'll do migrating to PostgreSQL. One of the biggest challenges for organizations is migration, so we'll provide you with actionable insights and tools for transitioning your workloads to PostgreSQL. Performance tuning after migration, ensuring peak performance is key. So we'll cover performance tuning best practices to get the most out of your Azure PostgreSQL deployment. Performance tuning encountered scenarios. To make this even more practical, we're going to share real world scenarios where organizations have faced performance bottlenecks and how we resolved them. And then finally, we'll open the floor to you. Bring your questions. Feel free to put them in the chat, and our team of experts will provide answers and actionable guidance at the end of the session for at least the last 10 minutes or so of this webinar. At Quadrant, we pride ourselves on bringing the best minds together to help businesses innovate and thrive. So, speaking of brilliant minds, I'm excited to introduce the experts joining us today. These are the folks who are going to guide us through the journey of PostgreSQL migration, sharing their expertise and real world insights. So, first, we have Pete Rodriguez. Pete is a principal partner solution architect at Microsoft with over 25 years of experience driving digital transformation and innovation. He specializes in designing and implementing scalable solutions that leverage the power of Microsoft Azure. Pete's expertise spans various domains, including application development, database platforms, and artificial intelligence. Known for his strategic thinking and technical acumen, Pete bridges the gap between business needs and technology capabilities. And in addition to his technical background, Pete has academic training in both computer science and music. Next, we'll have Mike Shelton. Mike is a Microsoft data and AI partner solution architect with more than 22 years at Microsoft. In his role, Mike collaborates with partners to understand business and technical requirements, mapping Microsoft solutions and technologies to address them. His expertise includes data strategy, cloud data management, cloud data architecture, and AI architecture. Mike has a strong academic foundation in computer science, data management, and predictive analytics. Lastly, we have Vinu Gopal. Vinu is the technical director for data migrations at Quadrant Technologies, where he leads the development of our database migration tool, Qmigrator. With over 20 years of experience in large scale migrations and 5 years at Quadrant Technologies, Vinu is a seasoned expert in the field of database modernization. Now, let me just give you a quick snapshot of who we are at Quadrant. We have over 15 years of industry experience. We've completed over 1,000 successful projects and built a team of over 3,000 professionals. We're proud to be a Microsoft Partner of the Year finalist for 2024, a featured Microsoft Fabric partner, and an AMMP certified to fast track cloud migrations. Without further ado, I'll hand things over to Pete, who will kick off today's discussion. Take it away, Pete.
Thank you, Allie. Yes, I'm very excited to speak with you today. So the first thing we're going to talk about is why you should consider Microsoft Azure for Oracle to Postgres migrations. And the first thing is to think perhaps about cost. And one of the great things about Azure is it allows you to reduce your upfront hardware and software costs by adopting a pay-as-you-go model. And this means that you only pay for the resources you use, and that can lead you to significant savings over time. And as you grow, of course, you can scale out the infrastructure that's required. If you know that you're going to be running workloads for longer term, you can take advantage of our 1 to 3 year reservations, which can save you significantly on the costs of Azure services. And then another great thing is that we provide migration tools that can help you move to the cloud. So we have a service called Azure Migrate that is commonly used to move virtual machines, but it also has a component in it called the Azure Database Migration Service, and that helps simplify and automates the migration process. It supports various database types, and that can ensure a smooth transition with minimal downtime. We've also invested heavily in security, and of course, that's top of mind with a lot of our customers, given what's going on around the world with hacking and such. And so we can protect your data through encryption at rest as well as in transit. And you can use either Microsoft provided encryption keys, or you can bring your own keys. And we also include features such as Microsoft Defender, which can give you advanced threat protection. We do automated updates for our Azure services to guard against vulnerabilities. In terms of global reach, we've got 60 plus data centers around the world, and that allows you to deploy your databases and applications as close to your users as possible. And that can improve performance and reduce latency for those applications. I think Ali mentioned I've been with Microsoft 25 years, and it's amazing to see how things have changed over the years in terms of our commitment and embracing of open source. And we are very heavily invested in open source software. In fact, we have the highest number of GitHub commits for PostgreSQL, which you'll see in a second. We have an easy ecosystem integration when it comes to how our Azure services can be integrated into the partner ecosystem of tools and products. And there are examples out there, for example, monitoring tools or FinOps tools, et cetera, database management tools that can manage Azure services. Then business continuity is very important, right? So you need to be able to back up your services and provide for disaster, and we can make sure your data is safe and can quickly be restored in case of an outage. And this enhances your overall business resilience. We've made a commitment to eventually deploy Azure services, all of the Azure services, into availability zones by default. In fact, we just did that for Azure DB for Postgres as of Ignite a few weeks ago. And then the last thing on the slide is, of course, talking about scalability and flexibility. I mentioned that a little bit on the first bullet with cost efficiency, but yes, you can scale up and scale down your resources based on demand. This includes CPU, memory, the amount of storage you might need. And in the case of database workloads, you can increase the number of IOPS that are needed for your application. This slide just shows the Postgres work streams at Microsoft as of May of this year, and we have 7 Postgres committers out of the 30 worldwide. Next slide, please. There was a recent survey on Stack Overflow as to which database developers preferred, and the #1 database was PostgreSQL. And there are a number of reasons for that. It is open source. The #2, MySQL, is also open source, although that's also managed by Oracle. But you can see perhaps your favorite databases up there as well to see how they rank. Next slide, please. So why migrate from Oracle to PostgreSQL? I guess probably the biggest reason might be it's going to cost less, right? And it's more cost effective to use open source. So you're eliminating that proprietary relationship that you have with Oracle and eliminating the software licensing that's associated with that, which can be quite significant. The second reason is because it is open source. If you needed to, you could make changes to the source code. And there are customers, especially in regulated industries, that have a need to do that. And you can modify that code as you require. The next thing is that there's a very significant community around Postgres. And if you're having a problem, you can reach out to that community for support. And it's oftentimes the case that within a few hours you can get an answer to your query. I showed the market share, so it is a very Postgres is a very popular database among our professional developers. In terms of interoperability, we integrate with tools like Azure Data Studio, Visual Studio Code, Azure Migrate. Of course, I put the Microsoft ones because I'm from Microsoft, but there are a number of other tools out there that can take advantage of integration with Azure DB for Postgres. Mike's going to talk a bit more in detail about our support for AI within Azure DB for Postgres, so I'm not going to go in detail on this one, but we do support vector embeddings and natural language processing. A newer capability as well is to support a small language model with AI. So if you know that you have a latency sensitive application, you could potentially do a small language model queries locally, and then that would improve the responsiveness of your application. And then lastly, Azure DB for Postgres is a fully managed offering. And this slide here talks about the differences between our flexible. We have two main offerings in terms of managed offerings for Azure DB for Postgres. The one that we most commonly recommend is Flexible Server. And the reason for that is because it's considerably less complex than the next one I'll talk about in a second, which is Cosmos DB for Postgres. But to kind of focus on Flexible Server for a second, it is a fully managed database service in the cloud. So what does that mean? It means that Microsoft is the one doing patching of the underlying operating system, as well as patching of Postgres itself. And so that takes a lot of that work away from you, and Microsoft does that on your behalf. We support high availability through things like, as I mentioned, availability zones and read replicas. So if you want to make sure that your database remains available, you can spin up a read replica, and in the event of a disaster, you could have that take over. I already mentioned the patching updates, but you can also scale up the database size and I/O as you need to. We do have automated backups up to 35 days for point-in-time restores. And another great feature that is that you can choose to start and stop your database servers in order to save on costs, and especially you probably wouldn't do that, of course, at a production database, but for dev test that can be very useful. And I mentioned about encryption at rest a bit earlier. Now, the other offering we have, Cosmos DB for Postgres, it allows you to support databases beyond what we currently support with Flexible Server. So today, and this is very frequently changing, perhaps it almost seems like every year, but today the maximum size of a database in Flexible Server is 32 terabytes, which is a lot, right? But if you had to go beyond that, then you'd want to look at Cosmos DB for Postgres, which has all of the features that I mentioned in Flexible Server a little earlier, but it also allows you to distribute your database across multiple servers. And that basically means you could be unlimited in size and compute. There is a trade-off because you would need to think about how you would partition your data, and that can be complicated, right? But that's why you have architects from Quadrant and Microsoft to help you with that endeavor. But with that, I believe I'm done with my slides. I'm going to transition it over to Mike, who's going to talk a bit more about the AI capabilities.
Excellent. Thanks, Pete. So now that Pete has set the foundation for Azure Database for Postgres, I'm going to talk about a few new and future capabilities for building intelligent applications with Azure Database for Postgres. Now, first, an intelligent application is an application that leverages artificial intelligence and machine learning technologies to provide advanced functionality and improve user experiences. So the first thing I want to talk about is the developer capabilities for Azure Database for Postgres. Now, Azure Database for Postgres seamlessly works with other Azure application services, such as Azure App Service and AKS. And as Pete mentioned, another developer capability is to use VS Code to develop in Azure Database for Postgres which is done as a VS Code extension and provides capabilities such as connecting to different Postgres instances, database exploration, and query execution. Now, AI applications often use large language models, or LLMs, to enhance intelligence, responsiveness, and user-friendliness. LLMs add value to customer service bots, content creation tools, and language translation services. Now, using your data with an LLM can be done through retrieval augmented generation, or what we call RAG. RAG aims to retrieve relevant information from your data and use it to generate accurate, contextually relevant responses from the LLM. Now, converting your data into vector embeddings, which are a numerical representation that capture semantic meaning, enhances this retrieval process. And vector databases are specialized databases designed to handle storing, indexing, and querying of vector data. Pgvector is a Postgres extension that enables storing, indexing, and querying of vector data directly in a Postgres database. And now, to enhance the indexing process, Microsoft Research has developed what's called DiskANN. And Microsoft DiskANN is a highly efficient algorithm designed for approximate nearest neighbor searching on vector data and is integrated with Azure Database for Postgres, now in limited public preview. And it leverages a disk-based storage approach to handling extremely large data sets that do not fit into memory, making it well suited for scenarios requiring high performance and scalability for your RAG application. Now, another area of advancement for RAG approaches is to use graph data models for efficient data retrieval. And Apache AGE is a Postgres extension designed to support graph-based data models and queries. By extending Postgres with graph database capabilities, Apache AGE allows developers to create, manage, and query graph data structures such as nodes and edges, which are essential for representing complex relationships and hierarchy within data sets. Now, Microsoft Graph RAG is an innovative capability to enhance graph-related operations. By leveraging the strengths of both Postgres and Graph RAG, developers can unlock new possibilities for data interconnectivity and relationship modeling, driving deeper insights. The Azure Database for Postgres Graph RAG capabilities are released as a solution accelerator that you can use with Azure Database for Postgres. Now, generally, you would have an application or data pipeline managing the creation of vector embeddings. But with the Azure AI extension, you can streamline this process by integrating advanced artificial intelligence directly into the database environment. Developers can leverage AI models for predictive analytics, anomaly detection, or natural language processing, all within the familiar context of the Postgres database. This seamlessly integration simplifies the workflow, allowing for more efficient data processing and analytics without the need for external data processing. An Azure AI local extension, as Pete mentioned, is this idea of using a small language model locally. Now, this extension in Azure Database for Postgres further enhances the database capabilities by enabling advanced artificial intelligence functionality directly within the database ecosystem. Now, moving on to some performance enhancements. The first is still on the current slide, please. The automatic index tuning, now generally available, is a feature for Azure Database for Postgres, designed to enhance database performance by automatically monitoring and adjusting indexes. This feature continuously analyzes query performance and recommends the creation of new indexes or the removal of existing ones that are no longer beneficial. By optimizing the index strategy automatically, it helps to improve query execution times, reduce resource consumption, and ultimately lower operational costs. Performance tuning, or specifically parameter tuning, now in public preview, is a crucial feature in Azure Database for Postgres that enables fine-tuning of database parameters to optimize performance. This feature involves adjustments of various database settings, such as memory allocation, cache settings, and query execution parameters to ensure optimal operation under diverse workloads. Elastic clusters in Azure Database for Postgres, now in public preview, offer scalable and flexible database management. And this feature supports seamless scaling by distributing workloads across multiple nodes and enhancing performance, fault tolerance, and availability. This is similar to what Pete just talked about with Azure Database, Azure Cosmos DB for Postgres, but in Azure Database Flexible Server. And finally, SSD v2, which is in public preview for Azure Database for Postgres, offers superior performance, reliability, and the latest SSD technology. It delivers fastest data access, higher throughput, and reduced latency, enhancing read and write operations. Now, let's take a quick look at some examples of using Azure AI Services and Azure Database for Postgres so you can see what this might look like in your own environment. So the first one we have is remote embeddings. And what we're doing is directly from within the database, within Azure Database for Postgres, we're making a call out to Azure OpenAI embedding models to do the vector embeddings and store them inside of the database. And then the second one is an example of using the local embeddings, where we're using this extension to call a local, in this case, a small language model. What this does is helps us reduce latency and reduce cost, because we're leveraging a model deployed locally and not having to go out to an external service to be able to do that. So these are great ways of enhancing AI applications directly from within the database, reducing the complexity of your overall architecture, increasing performance and scale. Now that we've discussed some of the new features and capabilities in Azure Database for Postgres, I'd like to turn it over to Quadrant to take us through the rest of the presentation.
On the AI space. So I'm going to cover migrating to PostgreSQL from heterogeneous and homogeneous databases, means from on-prem Postgres. And I will be focusing more on performance tuning. So the migration challenges, especially if you have to migrate from heterogeneous databases, like handling data type differences, we need to make sure the sequences are set at the same level, and code, all right, procedures, kind of PL SQL code to PL/PT SQL conversion, and performance optimization is very important. And any workloads or application changes that needs to be done, that they need to be taken care. That is going to be challenging as well. And there are several tools and techniques, right? If everyone is figuring it out, those that's going to be challenging. So data migration, depending upon volume and variety of data, and the testing and validation, and while doing the changes, while doing the migration, if there are any changes are happening in the production, right, handling that and making sure that we're having the latest, is all these are challenges that needs to be addressed when we're doing migration. So like here, if you see, like for heterogeneous databases, right, these challenges are very important, addressing those. And we did a detailed webinar in September, like about 3 months back. So we are going to post these links, right? You can go through YouTube video or directly from or go to Qmigrator.ai website. And that detailed webinar covers this migration process. And in regards to on-prem PostgreSQL to Azure PostgreSQL migration, Azure DMS supports it, and we do have the same capability. You can have the details in Qmigrator.ai website. So yeah, I want to focus more on performance tuning today. So the performance tuning we divided into 2 categories, right, based upon the various projects we delivered to the clients, right? These are more like OLTP databases and the data-intensive databases and all. So the way we have done is initially we have to do the query tuning, and once we address the query tuning during development or initial SIT or load testing using single user. Right. After that, we have to do the server tuning, right? So there are multiple steps we need to follow. I'm going to go through each one of them. what we have to do for query tuning and later for server tuning. So for first and foremost step for query tuning is to identify the long-running queries. Postgres has this pgstat statements where we can make a setting like to identify to capture the statements running longer than a particular time, right? Like it could be 10 seconds, and then it could be bring it down to 5 seconds or 1 second, whatever is the need that is needed for the business, right? We can make that setting, and we can capture those long-running queries. That is the first and foremost thing that we need to do the performance tuning, right? We have this capability in Qmigrator where we constantly capture this and keep it, even to go to history. I mean, usually it is not recommended to keep a lot of history in Postgres DB itself. So once we have this queries, then there are next steps we can do. That's the first and foremost thing that we need to do is to identify the execution plan. So doing the execution plan, right, like getting the execution plan, we can rerun the queries and get that execution plan, or we can also, because these are in lower environments, we can make a setting to actually, while query is executing, to capture those execution plans, right? So we have like these features in Qmigrator where not only like usually Postgres captures at a statement level, but we can also have this collect all the statements and put them together, map them to a procedure. So procedure level plans, right? We can capture that way, so that we can look at when we are trying to optimize at a procedure level, we know we have all the information. And when we store that in the Qmigrator, this plan procedures and their plans history, like when there is performance changing for a particular procedure, we can go back to the old plan and look what has changed, and whether it is because of the query changes, or is it because of any underlying like data increase or missing indexes as such, right? So, and having this history, we can also have a trend analysis, and we can identify the see what's coming. And usually these plans tells what we need to do, and indexes are very key for that, right? Most of the times adding indexes to the tables is what is going to help to increase the performance. So yeah, like especially when we are doing migrations, we need to make sure that all the indexes that are there in the source databases need to be brought into the target database. And then on top of it, we may have to add more indexes, right? So we need to identify the right indexes. Usually B-tree indexes are the most common ones, which can handle most of the performance issues, but there could be special scenarios to in that like having a hash or bin index, and for handling text data, gin index will help. So yeah, and knowing about composite columns, right? Usually we will create index on single column, but there could be situations where if you're creating an index on composite columns, that is going to be helpful. Just one thing you need to remember is do not query on the second column. If you're creating a composite index, it is not going to use that index, right? And duplicate indexes could be with the different names, but on the same columns, that is going to cause performance issues. So we need to make sure that there are no duplicate indexes. And we in Qmigrator, we have an index management feature which kind of helps on all this. So index monitoring is also important. It will tell like what is the usage of index, like whether indexes are being used or not. And as we see workloads changes, right, data increases or workloads, kind of the transactions that are done before maybe not done anymore, right? So having this data available helps to optimize what to do, like adding when we add new indexes or removing this duplicate indexes and all. Another aspect is knowing the index bloat, right? As you all know, Postgres, we need to do the vacuum to remove the bloat, but when we do that, it usually addresses at the table level, not at for the index. And that's why we need to know, and time to time, having a periodic reindex is important. So we have this capability of proactive index monitoring in Qmigrator. So when it comes to right, index is the easy, I mean, it's the first step anybody would do. But sometimes, just indexes might not help when, especially when the data is growing in a table, and index is very large, right? So that's where partitioning comes into picture. The concept of partitioning is you have a very large table with a lot of data. Right, you're splitting that into multiple tables so that you're keeping your index sizes small, right? So what is important is identifying those large tables and what are the columns that are being used, especially in the filters, and and how the other tables are being partitioned. All this analysis is needed for partition key selection, and Qmigrator does that partition analysis automatically, and it recommends. So yeah, we learned two techniques, creating indexes and creating partitions, but that may not solve all the problems. Doing query rewrites is also very important, right? We need to look at these SQL statements, and we may have to do some changes. So some of those I'm covering now. It's like typecasting is one important. Like we need to make sure, right, both sides are in the same data type. Or sometimes indexes, if there is a function in the index which is already having a casting, we need to make sure that we are using that index, right? And if you are creating an additional index without that, and that is not going to be helpful. So and the next technique is temporary tables. Temporary tables, right? Like if you're having some joining the same tables again and again multiple times, and if the tables has large data, so it is important to write that rewrite the queries first. Take the data from that large table, put that into temporary table, and if needed, you can also create an index on that, and then uh, again use in the subsequent queries, use the temporary table to join. That is very efficient way of addressing the performance issues. Common table expression is a similar concept, but when the data is not as big as that needs to go into the temporary table, if it is can fit it in the memory, this is better option. And for like a recursive queries and as such, CT is a good technique. So yeah, by default, means based upon the server setting, there will be parallel execution on the queries. But if a particular procedure needs more parallel execution, we can do some settings change for that particular procedure itself, and increase that parallel execution. And another concept is using index hints. Well, like it is recommended not to use index hints on Postgres. It does a good job by itself. But in just, there could be like you exhausted all your options, and that, making a particular index use is going to definitely help that time, give this index hint and see how it is working. Yeah. So I think whatever so far I have covered, right? I have covered is, the first category, how you can improve the query performance, right? That is, those are the techniques. But then once we done that in the lower environments, like in the development or SIT, sometimes it could be even in UAT also, but or in the load testing environment with single user testing. So that queries are optimized. Now we need to do a server level optimization. Server level optimization means you're running a load test. I mean, you could start at a 5% level and go all the way to 100% level, or you deployed into production, and after deploying into production, you need to monitor and then improve the server performance. You need to do the tuning, right? Most of the time we should we should take care in the load testing environment, that one. So when we are doing a server tuning, the important concepts here is to watch for is logs and blocks, right? Postgres has this the log types are access share logs. They are not they're good. The architecture of MVCC itself will make sure like any number of reads we can do, that is not going to cause anything. But whenever we are doing this DML operations, then it is going to have an exclusive logs. And with the DML operations, if at all there are any DDL operations like altering tables or any table maintenance operations like vacuuming or reindexing, these tables can be logged. This is where the logs are going to block the transactions. All right. So here, like if an index is missing, right, that could be, and if you are trying to update the table, it is going to take more time. And we are also want to another update on the same row, then that is waiting, right? So having an index is going to make that update fast, and then lock is going to live for a very short time so that there is no blocking. So that I think I just mentioned that example, like right, modifying a row and another one could block it, right? But making sure that these are living very short period of time, these logs, then that is going to be good. So continuously monitoring these logs, right? pgstat activity is a useful table that is going to, it can tell about logs and blocks. There is also a PG logs where we can identify, we can get the logs information. So I'm just giving an overview of the things, but not actual, right, exactly what system tables you need to go and the queries. I think, that could be, you can get that information very easily. So once we address those things, right, then server tuning is another important area. So for server tuning, like we have identified some important parameters, like addressing like shared buffers, like work memory, how much work memory we need to allocate for each query it is going to use. Maintenance work memory is like for doing vacuuming, those kind of activities, how much memory we need to allocate. And the effective cache size, this is more for a planner. It should be very high value. And auto vacuum settings, like parallel workers per gather, and like temp buffers, and ideal transaction timeout. These are all important parameters to set to fine tune the server. Right, means there are no, this has to be based upon the workload. As your workload, that's why a load testing environment is very important. That's where when you test it, you will know how the server behavior, and you need to tweak this server level parameters. But you should be aware that your load testing might not cover all the transactions in your workload, right? Because you might not be able to do 100% transactions coverage. So you need to be watchful in the production environment, right? As new things, new business use cases are added in there and new transactions, then the behavior could change. and you need to understand that workload and tweak these parameters. The good news, Mike also mentioned that there is a feature coming to have this based upon the workload. Azure can optimize these server parameters. It can suggest and you can do the change. Right, this is very important feature that's coming. So yeah, as we worked on many of these projects, OLTP, applications that are migrated, very complex with a lot of code, PL SQL code converted into PLPG SQL, and we did performance tuning. Some of the scenarios that we encountered during performance tuning, we would like to share that. So yeah, the having an auto vacuum on is periodically Postgres monitors the tables and takes away. But if it is heavy in transaction, if the database is heavy in transactions, right, those changes into the tables will also changes the system tables, right? The bloat is also going to increase system tables. So just leaving it for auto vacuum may not be sufficient. We have to proactively schedule the jobs to look into these system tables and address. We need to vacuum them to take away the bloat. Right. In one of the applications, we have to even go for 5 minutes. Every 5 minutes, we need to address that bloat in system tables. So this is another important thing that we encountered is excess partitions. Right, partitions usually should be able to help, but we brought all the partitions from Oracle into Postgres, but we were not able to cover that. I mean, the load testing also we having a similar environment. But it is not able to cover because there might not be some transactions did not come into play when we did the load testing. But we have seen this performance issue across the board after going to production. Right, these partitions having excess partitions causing system performing poorly, and that's where we have identified that removing some partitions will reduce scans, and then it increase the performance. So yeah, just we need to be aware of that as well. And turning off logging, right? Logging should help us in terms of capturing the queries and all. But in production, that is going to create an additional overhead. So you got to be aware of that. So buffer cache monitoring is right, like everybody knows, like who is working on database, like if data is coming from the buffer cache, that is going to help for the performance, right? So when it cannot be 100% the hit ratio, because that means you're keeping the whole database in the memory, and so it's good to have like close to 99%. That means the change is very slow, right? Only you're keeping most of the data is in memory, and there is a data change that is happening in the buffer very slowly. So and like anything between 95 99 is good, but below 90% we consider as poor. We need to see what is happening with the buffer cache. Like, is there any tables that are taking more space, and it is too much of rotation of the data that is happening. So yeah, that's exactly is there in here. Like if some of the tables or some of the partitions are occupying more, then how we can make it better and reduce their usage of buffer cache so that the others can take advantage of the buffer cache. So this is again a similar thing, right? Whenever data has to come into the buffer cache, then it will put a lightweight locks. That could be lightweight lock contention. So it can once it grows, then that's where it can go out of hand and it can cause server performance issues. Means there is a workaround to allow more of this by changing the setting max logs, but that means as long as it is manageable, that setting is good. But in general, you want to reduce this lightweight log contention. So application slowness issue, right? I mean, there could be many things that are happening on the application slowness, like having the effective cache size, which is buffer cache, and what is the work memory setting. Again, this depends upon what is your workload, like how many active connections that's being used, all that, right? And vacuum out of vacuum scale factor, right? And your PG bouncers, like a connection pooler is very important to use, and having transaction mode, setting that into a transaction mode is really helped in our workload, right? And having a right pool size and timeout, all these parameters are important to make sure that your workload is performing optimally. So here again, for a typical for a server for 32 cores, 256 GB, the kind of settings we need to get into for an optimal performance. I just have put that in the slide. So I'll actually also spend a few minutes in showing the kind of before going to Q&A. I'll show our tool Qmigrator and how it is addressing these performance issues. So thank you for that, for the wait. Here it's a Qmigrator tool. So this is our migration tool, and we added the modules, DBA module and performance tuning module. So for migration, we do the assessments, we do the code migration, we do the data migration, deployments. This is where like any production changes, we can address it, and we can identify the production changes and have those changes incorporated into our migration environment, right? We have a testing module that we can capture the workload and execute them as test cycles, so that we can know the functional issues and performance issues. And our DBA module does a lot of these activities, like handling the security and as well as vacuum analyze and having the health check reports. But today I want to cover this performance tuning, right? In the performance tuning, it's the same sequence that I have covered, right? We capture the long running queries, having the log explain, capturing the data at a procedure level, and then having there are multiple index tuning, duplicate identifying duplicate indexes, like we have an index monitoring process. And then we do have table partitions, which suggests which tables, right? By running this, it suggests the candidates tables that needed partitioning and what are the partitioning key columns. It does that, and queries insights give much more information on the queries that are running in production, right? I'll want to go through some reports here, right? We have a long running query reports, and we have an log explain plan. Maybe I'll open this and show you. So here, and it's when we capture, a procedure, we capture all the statements and put together under that procedure the different statements that are being executed and their execution times, and we are capturing their plans. So if you see, and these plans will helps us what is happening and where exactly how we want to, whether we want to add indexes or partitions, or we have to manually tweak, do manual changes, right? It is going to help. And like when we are, if you see, these are multiple runs. We ran here this particular procedure, and we also ran in the next one. I think that's a schema name, but there could be p-order details here, number 1, and here at number 7, right? So yeah, that's that. And I think as such, there are many reports here. So we got to, I'm not going to cover all. I think we are running out of time. I'll want to leave some time, 10 minutes for Q&A. And I think I just want to have one more point to stress this. Like by doing, helping the clients doing migrations, means our team learned so many things, so many techniques in performance optimization. And in some cases, we have a help from Microsoft, their database engineers, their like engineering team, and their solution architects like Pete and Mike. We reached to them to get additional help, and we also have reached to product team as well in addressing some of these issues. So together, we help make sure that running the applications very smoothly. Yeah, thank you.
Awesome, Vinu. Thank you for that. That concludes the main part of our webinar. We hope you found the insights and strategies we shared today valuable. Now, we would love to hear from you guys. So let's move into our Q&A session. If you have any questions about Azure PostgreSQL, its features, or anything we covered, drop them in the chat, please, and we'll address as many as we can. Looks like we have a few already, so we can get started there. How about Pete? What are the major challenges organizations face when migrating to Azure PostgreSQL, and how can they be mitigated?
Yeah, and Venu, I know you probably have a lot more hands-on experience with customers to deep dive into this, but at a high level, I think it depends a lot on the application and how it was written. If people were dropping queries directly in Java code or .NET code, whatever it happens to be, right, it could be a significant effort to go through that and find all the places where that was done and replace it with the equivalent Postgres. And it's not that that's particularly difficult, it just takes time, right? And to have to redo testing and performance and make performance testing as well and make sure everything's working the way it's supposed to. Oh, I didn't put an index on my database where it was before in Oracle. I mean, so Benny, I probably, again, like you're going to have a lot of real world things. So
Thanks.
Take
Thanks, Pete. I'll add a couple of things, right? Means it's not that migration, it's a repeated processes in migration. Like, you have to do your conversion, make sure that the executions are happening, and functionally they are okay, and performance tuning, we need to address that performance tuning. These are the activities, but like knowing, like we need to have a right tool to have these things like we have to spend time in not identifying the issue. In all these areas there could be issues. So like we want to automate these things as much as possible, but if at all there are any issues, people should spend time in resolving the issues, not identifying the issues. So yeah, thanks.
Awesome. All right, here's the next one. What are common reasons for migration failures to Azure PostgreSQL, and how does Microsoft help organizations avoid them? So Mike or Pete, I think you guys can take this way.
Go ahead, Pete. Do you want to just build on what you had from the last question?
Yeah, I mean, it's a very similar question, perhaps. And I think I hate to see the word failure there, because I think it all depends too how much someone is willing to invest in the migration. I mean, we do have access to the Postgres team, and they're going to want to help you as much as they can. And we actually have an internal distribution list I know we can use, but also I think they have one like externally for people to reach out to them in terms of any challenges they might be facing with the migration. itself. But I mean, there could be some, if you had a 64 terabyte database, right? Well, that's bigger than what we have in flexible server. So at the get-go, right, that could be something that might prevent you from moving to that. So then we'd have to think about, well, can we realistically take advantage of Cosmos DB for Postgres, which would remove that barrier in terms of storage size, right? But again, it would require that we look at your application and database to see how practical it would be to partition the data and is it going to work, right? But Venu and Mike, I don't know if you want to add on to that.
Well, I'll just add something just really quickly. I think that the biggest thing that that I've seen is maybe not having a great understanding of the performance and usage characteristics of the application in its current implementation. And I think as Venu walked through earlier and the Quadrant team has demonstrated very detailed, having a good understanding of those performance characteristics as you move to Azure, because you're moving to platform as a service, and some of the characteristics in the way that the infrastructure behaves is going to be slightly different, and the performance and scale is there. It's just as you make that transition, understanding what your expectations are and being able to size appropriately to the destination is a critical element. And I think the tools that we've seen today are great examples to be able to help with that transition. Is just slightly different for what folks might be used to today from where they're coming from. Vinu, anything to add?
Yeah, that's great points. I think know what are the limitations, like Pete mentioned, that limitations, and having like giving importance to the performance tuning Mike mentioned, right? That is very important. But of all, like having the mindset, we are going to PostgreSQL is very important. Like, there will be hiccups, but we are here, Quadrant and Microsoft, to solve those challenges and get to reach you to the endpoint.
All right. What is your approach for migrating from databases that support columnar storage or vectorized execution? Mike, do you want to take this one away?
Yeah, I'd be happy to. And if I'm not answering the question, maybe add some clarifying points. I'm assuming that this is either you're migrating to Postgres from a database that's maybe a dedicated vector data store or something like this. So based on that approach, again, with Qvector as an extension in Postgres and in Azure Database for Postgres, there's great scenarios of leveraging what you would be already familiar with in an existing data platform and just adding the vector capabilities to that. And that's what we see with that extension. That's what we see with the Azure AI and Azure local AI extensions, to really be able to add these feature sets to your existing database, in this case, Postgres, as opposed to having a separate dedicated vector data store. The capabilities with Qvector, with the different index types that we have, HNSW and IVF flat, that you can have that are in Qvector, or with the Microsoft Disk ANN, really help you address the scale question when you're doing similarity searches. So I would say if you're looking at a dedicated database for vector capabilities, looking at Postgres and how that can add to your existing application are a great place to look at. And hopefully some of these points I've mentioned would give you some things to think about. And if that didn't answer, if you have a follow-up, I'd love to be able to explore in more detail.
Awesome. I guess, Mike, this is another one for you. How much control do businesses retain over their database configurations? And how does Azure PostgreSQL balance this with the constraints of a managed service?
Yeah, I would say I think you've got a really good amount of control over your database configurations. I would start with the fact that anything that you have at a physical OS layer, you're not going to have access to as a platform as a service scenario. So if you're using things that are outside the environment itself, then those would be certainly considerations. The one area that you may have some area to investigate for sure, and some differences, would be in the extension ecosystem that you have. You cannot just bring any extension for Postgres into the Azure database for Postgres environment. There is a significant number of extensions that we do support, and we're continually adding those. As I mentioned in the presentation, we added the Graph extension, which is a recent extension. PG Vector, when it became available, was a recent extension. So there are a large number of extensions that you have available to you, but maybe not all of them. So that is some things that we've run into in the past. Other than that, performance characteristics inside the database, your database configuration itself from the parameters, you got pretty good control over there. There may be some edge cases, so I don't want to say that you have 100%, but I think the balance of, as we've talked about today, some of the things that are managed for you, giving you the time to really focus on the database itself and the application, provide significant benefit and a strong trade-off between managing that on your own. But hopefully those points I mentioned are probably the couple that are the most things to consider. And then Pete, Vinu, if there's other things you've run into, feel free to add to those, but that's what comes to mind for me.
Oh, that was great, Mike.
Great, Howard.
Awesome. So many organizations are hesitant to migrate without clear evidence of financial benefits. How can you quantify the ROI of migrating to Azure PostgreSQL, and what metrics should businesses track to ensure success? Vinu, did you have something on that one?
Yeah, I can take those questions. This is where accurate assessment helps, right? We have a standalone assessment tool as well, which does the server scan, which can do the database scan, identify database level, things like, let's say, Oracle. And the actual code, it scans the whole code and gives a detail what features will be automatically converted, what features need manual intervention, and how much time it needs, right? It gives a detailed assessment. And then it can also scan the reports like AWR reports and identify what are the SKUs that are needed in Postgres. And having all that information, we can have a clear picture, like what would be the migration cost and what would be the like your TCO, total cost of ownership. And then that way we can identify the ROI before we can make a decision.
Awesome. Thanks, Vinu. This question is for Pete. Can Microsoft guarantee data security and protection against breaches in Azure PostgreSQL, even in the face of sophisticated cyber attacks? And how is accountability handled in such cases?
Interesting question. Yeah, I mean, for actual data breaches, we can't exactly guarantee that you're never going to get hacked, right? But we do have a rigorous schedule when it comes to things like applying security patches for the service, and that's done automatically, and that includes both the underlying operating system as well as Postgres itself. And again, we do encryption in transit and at rest, because if somebody were to get in there, if they tried to take the data, if the data is encrypted and they don't have the decryption key, they're not going to be able to do anything with it easily, right? It could take them hundreds of years potentially to be able to access that. And then network security, I think that's important, and taking advantage of tools like Microsoft Defender that can help with that, and SSL, of course, is important. So only connecting and making sure that the people that have access to your database are the only people that should, right? And I think that's another key tenet when it comes to how you handle data security.
Awesome. Thanks, Pete. This is going to be our last question here. What are the biggest risks companies face during the migration process? And I think we kind of went over one similar to this already. How does Microsoft help mitigate these risks to ensure a smooth transition? Maybe
I'll take that. I'll
Yes,
make
please.
it quick, right? Microsoft is always there. Like, we have seen very complex migrations, and we were able to get the team experts help from engineering team, and sometimes directly from product teams and the solution architects and all. They jump in and they help. That is it's very awesome. Like, we are really great to have such kind of support from Microsoft, I would say.
Awesome, awesome. I will say, since we kind of did that one, we kind of touched on that a couple times. Let me do one last one because I saw this in the chat just now. Why should a business choose Azure PostgreSQL over competitors like AWS, RDS, or Google Cloud? Anyone who wants to answer this one, go right ahead.
Well, I was going to say, Pete, why don't you cover those first parts as to why Azure? So I think that just really ties nicely into the overall ecosystem from that perspective.
Yeah, I mean, all the cloud vendors have similar offerings, and I think part of it might depend on how invested you are in a particular cloud vendor itself, because I mean, we're commonly leapfrogging each other when it comes to capabilities, right? So if you had asked me this question, say 4 years ago, when our offering was single server, I would have been doing a lot of tap dancing. I'll put it that way. But our offering today is much more competitive, and I would say it's superior, and especially with the Cosmos DB for Postgres offering, which the other guys don't have, right? So if you really wanted to have that insurance policy against being able to not handle more than 32 terabytes today, right? Like the other guys can't say they have unlimited storage. Those they do say they have something that is read only, but I mean, we're talking read write in multiple nodes within your Postgres environment. That's what we have with Cosmos DB for Postgres. So that is a unique offering that we do have.
Awesome, awesome. Thank you, Pete. And thank you all for joining us today and for your engagement during this session. We hope you're walking away with a deeper understanding of Azure PostgreSQL and how it can empower your database operations. If you have any further questions or want to explore specific use cases, don't hesitate to reach out to us at quadranttechnologies.com or find us on LinkedIn. Have a great day, and we look forward to connecting with you again in our future webinars.
Thank you.
Thanks, everyone.